not possible to find time constant. In that cases, we need to go for the tau. It is not, sometimes it is not possible to find the time constant. In that cases, we need to go for the Laplace transform approach only. Right. Fine. Now let us see some problems, and if we see the some basics of this Laplace transform. Now here we can see the del of t Laplace transform is what? 1, and k into u of t. What is the Laplace transform for this thing is k by s, and e power minus at is what? 1 by s plus a, and sine omega t Laplace transform 1 a by s square plus omega square cos omega t is what? S by s square plus omega square. So e power minus at into sine omega t, and this Laplace transform is what? A by s plus a whole square plus omega square, e power minus at into cos omega t, and this is s plus a by s plus a whole square plus omega square. These are some Laplace transform basics we are required. Now see this first problem here. In the figure, 1 second, the resistor Laplace transform is what? R only. Here is ohms and this is the ohms. Next, in the cases of a inductor, and the Laplace transform is what? SL. Now what are the units of ohms? Capacitor, units of farads now, and after converting Laplace transform, what this is? SC. What are the units of ohms? Units of ohms mean that is like a resistor only, isn't it? No. See this problem. In the following figure, C1, C2 are two ideal capacitors. C1 has a charge of 12, the given, and before switch initial value given, and C2 is uncharged. C1 has a charge but C2 is uncharged. So let us find the I of t here. Now C1, this is the capacitor C1 here. This has a charge. How much charge they are saying is 12. This is C1, and this is another capacitor C2. That's all now here. Switch is closed. They ask me to find the current after switch closed. So this current, let us convert into Laplace transform. Then we can say 1 by C1, 1 by SC2. Now the units are ohms now, like a resistors, and 12 by S now. So this current I can call it as what now? I of S now here. Tell me I of S now here. Supply the resistance simply. So that is what now? 12 by S by what? 1 by SC1 plus 1 by SC2. I can simplify this thing. What I will get now? 12 by what? S cancel now. C1, C2 by what? C1 plus C1 into C2 now. C1 into C2. C1 into C2. This is E of S now here. So this is I of S is what now here? It is 12 C1 C2 by C1 plus C2. So from this I of t, which is given as inverse Laplace now, 12 C1 C2 by C1 plus C2 into what I can say? Del of t. inverse Laplace transform. So what is the function now here? Impulse signal. Right. Next one, DC excitation. RLC network. We are applying a DC supply. Then what happens now? Consider resistor, inductor, and capacitor. Of course, we apply series connection. We are doing first. So this is supply R, L, C. So this current I can call it as I of t. So write the KVL equations now here. V is equal to R into I of t plus L into d I of t by dt plus 1 by c into integral of what? I of t into dt. So DC, V is a DC value, constant value. So differentiate on both sides. Then what I will get? 0 is equal to R into di by dt plus what? L into d square I by dt square plus 1 by c into I now. So from this what I can say, this is d square I by dt square plus what? R by L into di by dt plus what? 1 by LC into I equal to 0 now. It's equation. Now converting this network, this equation to S domain. So S square plus what? R by L into S plus 1 by LC into I of S equal to 0. So the characteristic equation I can say S square plus what? R by L into S 1 by LC equal to 0 now. We know the characteristic equation of a second order system come from the control system. S square plus 2 zeta omega ns plus omega n square equal to 0. I can compare this thing here. So from this I can say omega n is equal to 1 by root LC and 2 zeta omega n is equal to 1 R by L. From this zeta, which is given as R by 2L into square root of LC. So zeta is how much? R by 2 into square root of C by L. This is my zeta. So as we know, from zeta we can able to decide the response of the system. If zeta is equal to 0, then we can call it as a undamped system, undamped response. If 0 less than zeta less than 1, we can call this as what? Underdamped. Yes, if zeta is equal to 1, we can call this as what? Critically damped. If zeta greater than 1, we can call this as what? Overdamped. So for the series network, according to zeta, we can decide now. Just remember this formula. Zeta is equal to what? R by 2 into square root of C by L. R by 2 into square root of C by L. From this, we can able to identify this thing. Right. Next we'll see this thing has the ESE transients here. So in the AC transient, the major part is transient free response. How to avoid the transients? Yes, consider a RL network, series RL network. Consider series RL network, RL circuit. Now let us consider that at t is equal to 0, my switch is closed. We are applying AC transients. This is my V of t supply, and this is my R, this is my L. Now at t is equal to 0, we are not applying any supply here. So what I can say now here, and this current I can call it as what now? I of t. What is this thing? IL. IL is nothing but I of t only. So what I can say here, IL of 0 minus, and which is nothing but I of 0 plus only now. How much is value? 0. Since no supply, before closing the switch, no supply. Yes. Next, after closing the switch, let us observe the analysis now here. Apply the KVL to this loop now here. So we can say V of t, which is equal to what I can say here, R into I of t plus L into d I of t by dt. So from this, what I can say here, d I of t by dt plus what, R by L into I of t, which is equal to what I can say, V of t by L, V of t by L. So we need to find the solution of this equation. The solution of for this I of t, which is given as what now here, CF plus PI now, complementary function plus particular integral. Let us find the complementary function first. Complementary function. For complementary function, we should make the right side value 0 now. So let us find the CF now here, complementary function. Then what I can write this equation now here, d I of t by dt plus what, R by L into I of t, which is equal to 0. This I can say d plus what, R by L into I of t equal to 0 now. Then we can get the complementary function I of t, complementary function, which is equal to something C1 constant na, e power minus what, R by L into t. This is what, complementary function. Now let us find the particular integral. Yes, let us find the PI, particular integral. Tell me particular integral, what we can do here. We'll operate now here. Yes, you can write I of t, which is equal to what I can say, BL of t by L by what, d plus R by L, d plus R by L. Now we'll see about the supply here. Supply, what is supply is here, V of t. Let us consider, let supply V of t, which is the form of Vm into sine of what, omega t plus some theta. Let us consider this V of t. Then I can find I of t as what I can say here, this is Vm by L into what, 1 by d plus R by L into what, sine omega t. And we should operate the sine now here. For this, we should replace d square equal to minus a square. That is d square equal minus omega square. But here, not d square now. So what I can do, we'll do the rationalization. dm Vm by omega L. So we can say this as d minus R by L into sine of omega t plus theta by what, E square minus R square by L square now. Check it. Simple mathematical analysis. So I can write this as what now here? Vm by L. Now this is d minus R by L times of what we can say? Sine of omega t plus theta by what? D square equal to what now here? Minus omega square. Replace now here minus omega square minus R square by L square. So from this I of t, which will get it as what? Vm L minus Vm by L by what I can say it is a R square plus omega square L square, and into what I can say now differentiation of this thing now. First if I differentiate it now, what I will get it is a omega cos of omega t plus theta minus R by L into sine omega t plus theta. So this is I of t. Finally what we can get, check it now here. This is Vm by, I can write this as a Z. Yes, mod Z square into, I can say this as omega L, yes, by mod Z, sorry, one Z I can remove here, mod Z into cos of omega t plus theta minus R by mod Z into sine of omega t plus theta. Check it. So finally if I write like this, so this is I of t, which is equal to Vm by mod Z into omega L by mod Z into what? Cos of omega t plus theta minus is there now, minus R by mod Z into what? Sine of omega t plus theta. So from this I of t, which is equal to what I can say here, Vm by mod Z, this equal to so that is R by mod Z into sine of omega t plus theta minus omega L by mod Z into cos of omega t plus theta. Here Z, what we have taken, it is a R plus j omega L. So that is phi is given as what? Tan inverse of omega L by R now. So this angle, we can say this angle is phi. This is omega L, this is R, and this is a mod Z. So from this, what I can say, sin phi here is omega L by mod Z. Cos phi is what? R by mod Z. So from this, get them here. I of t, which is equal to Vm by mod Z into what I will get now here. You can see R by mod Z. Can I call it as cos phi here? cos phi into sin of omega t plus theta minus omega L by half. So this is sin phi into cos of omega t plus theta. So from this I of t, which is equal to Vm by mod z into this, I can say sin of what, omega t plus theta minus pi, I can say. And here this is what, particular integral. Previously we got the complementary function here. Now the total expression of this current I of t, which is given as Cf plus Pi. Cf is C1 into e power minus of what we got, R by L into T plus Vm by mod z into sin of what, omega t plus theta minus phi. So we should get the C1 now. How we can get the C1? By using initial condition. The initial condition at t is equal to 0, current is 0 now. So let us apply this initial condition at t is equal to 0. I of 0 is 0 now. Initial current is 0. So this is 0 is equal to C1 plus Vm by mod z into sin of theta minus phi now. So from this C1 will get it as minus Vm by mod z into sin of theta minus phi. This is C1. So this C1 value I can replace here. Then I can get this expression. What I can get the final expression now here? C1 is minus Vm by mod z into sin of what? Theta minus phi into e power minus of R by L into T plus Vm by mod z into sin of omega t plus theta minus phi. Now this is the complete expression of current. This is the complete response equation. Now what we need here, transient free response. Here the first term, and this is the complementary function now. This complementary function is called as a transient response. Is called as a transient response, and this is the Pi. The Pi, which is called as a steady state response. Steady state response. Now you tell me here, for the transient free response, for transient free response means what the meaning of this is? There should not be any transient part now here. So mean the transient part, this is the transient part or not? So this transient part must be 0. This term must be 0 means what should be 0? Sin of theta minus phi must be 0 for transient free response, isn't it? If it is 0 means for theta minus phi equal to 0, and theta must be equal to phi now. What the phi? Tan inverse of what? Omega L by R. So for the transient free response, the condition is what? Theta must be equal to tan inverse of omega L by R. So theta must be equal to what I can say? Tan inverse of omega L by R, I can say as a tau, I can write. This is the condition of a transient free response. isn't it? And here supply, what is supply we have given? We assume that supply which is in this form like this, isn't it? And what we assume that here at t is equal to 0 switch is closed. Instead of that, let us say t is closed, switch is closed at t is equal to t naught, not at 0 other than 0, let us say. Then what happens now here? Then I can say t naught minus at t is equal to 2 seconds. Just before 2 seconds there is no supply. The t naught t is equal to t naught with the switching action. Before that there is no supply. Then I of t naught plus, how much this value will become? 0 now. What we can do here? We should apply same condition here now. See this equation now. This equation we can modify this thing here. The current express same thing you will get now. And find the initial condition we need to see. That is what now here? Vm by mod z into what? Sine of theta minus phi into e power minus of r by l into t plus Vm by mod z into sine of omega t plus theta minus phi, I can say. At t is equal to, when at t is equal to t naught, the current is 0 now. I of t naught is how much? 0. Apply this condition now here. So this is 0 is equal to minus Vm by mod z. Now this is, this is after getting this expression. This is what now? C1. We need to get a C1, we should get already C1 C1 we should get. So we will get C1 into e power minus of what now here? R by L into T naught now plus what? Vm by mod z into sine of omega T naught plus theta minus phi now. So from this, can I get the C1 from here? Minus Vm by mod z into sine of omega t naught plus theta minus phi into e power of r by l into t naught, minus will become plus. So this is C1. So from this, can I get a final expression now here? I of t, tell me I of t is minus Vm by mod z into sine of what? Omega t naught plus theta minus phi into e power into what I can say? E power minus of, I can take r by l common, then you will get t minus t naught. Do simplify carefully, we will get like this. And the Vm by mod z into sine of what? Omega t plus theta minus phi. This is as it is. Again, now this is the transient response now here. This is the transient response. Yes, transient response is 0. Means what I can say here? For transient free response, what the condition must be, I can say now here? Sine of omega t naught plus theta minus phi equal to 0. From this, omega t naught plus theta, which is equal to phi, I can say. Omega t naught plus theta, which is equal to what I can say? Tan inverse of omega tau, I can say. Omega tau I can write now. Isn't it? This is the condition for transient free response if the switch is operated at other than t is equal to 0, some other time. Now one more thing here. Here supply, the supply we have taken to is a Vm sin omega t. We have taken a Vm sin omega t supply. That's why the expressions we got it is a sine. Here the sine we got. If it is a cos, if I have taken the supply, if V of t is equal to Vm cos of omega t plus theta, then here in place of sine I can say we'll get cos. In place of sine here we'll get a cos, except that no change. Then what happens now here? Again here this is the transient response now. So tell me, for the transient free response the condition must be what I can say? Cos of omega t naught plus theta minus phi must be equal to 0, means what? Omega t naught plus theta minus phi must be equal to what? Pi by 2. So from this what I can say? Omega t naught plus theta, which is equal to what I can write now? Pi by 2 plus theta. Now this is the condition for transient free response if the harmonic term is a cosine function. If it is sine, this thing. If it is cos, this thing. Yeah, this is fine now. Right, finally we'll conclude this thing here for transient free response. Transient free response, we can say. For the transient free response, the condition we need to see here. The first thing is the same relation for the RL and RC also. Condition, you can say source means supply, and then first RL circuit, and RC circuit. We'll see this thing here. Let us say that supply, which is in the form of V of t is equal to Vm sine of omega t plus theta, and I assume that switch is closed at t is equal to t naught. In case of RL network, what the condition we have seen, it is a omega t naught plus theta, which is equal to what? It is sine harmonic now, so it is tan inverse of omega tau, where for RL network tau is equal to what? N by R. Now this RC network, tell me here, omega t naught plus theta, which is equal to, and tan inverse of what? Omega tau, same, but for the tau here, the tau is RC. Now let us say this is the harmonic function, which is the form of Vm cos of omega t plus theta. The switch is closed at t is equal to t naught. And in this case, now what we can say here, in this case, omega t naught plus theta, which is equal to what? Pi by 2 plus tan inverse of omega tau. Here the same thing, omega t naught plus theta, which is equal to pi by 2 plus tan inverse of omega tau, and tau RC here, the tau is L by R. That's all. Like this we need to see, isn't it? This is about the transient analysis. In the next class, we'll start the next chapter. Fine. Right. Bye.